that.
2 miles above the Rocky Mountains, warm, humid air rises, forming massive, billowing clouds. Driven by the winds, a sailplane carries research scientist Bruce Miller among these towering formations, where a storm is about to be born.
I head into the storm to measure electrical charges on water droplets in the cloud. We're trying to understand the fine details of what causes lightning.
Bruce's job is to get close to lightning, just not too close.
I think I just took a hit. Still good climb.
To understand the nature of a storm, you have to get close to it. Get inside it if you can. That's what storm chasing is all about. Stormchasers are scientists who gather information and track down clues to the mysterious forces that create our weather. They're found all over the world. In India, meteorologists use weather balloons, satellites, and supercomputers to track the largest storm system on Earth, the summer monsoon. It's a rainy season that lasts for months. Each June, Indian scientists record their observations to predict when the monsoon will begin. It can mean the difference between water and thirst, food and famine. The onset of the monsoon is always cause for rejoicing. By midsummer, the monsoon blankets most of the Indian subcontinent. The monsoon is part of a large global system, immensely powerful. As viewed from space, the Earth is a stage upon which a dynamic atmospheric drama is continuously performed. Storms begin with the heating of the land and the sea by the sun. As the sun heats the water, it evaporates, adding water vapor to the air. The warm, moist air rises, then cools and condenses to form clouds made up of millions of water droplets. This transformation provides the energy that gives life to powerful storms. to that the rotation of the Earth and the shape of the land, and the result is an interaction of forces so complex, no two storms are ever exactly the same. The most severe storms are often smaller in scale than the monsoon, and much more difficult to predict. In late summer, tropical storms lurk off the coast of Africa, feeding on ocean water warmed by the summer sun. As they cross the Atlantic, most die out, but a few turn into hurricanes. A hurricane is a vortex of fiercely rotating winds, releasing huge amounts of energy. In the center is a clear and peaceful eye, surrounded by the eye wall, a churning swirl of rising air and water condensing to rain. Every year, a few hurricanes with winds of 100 miles an hour move relentlessly toward the North American coast. In 1900, a ferocious hurricane devastated the city of Galveston, Texas. 6,000 people died that day. It remains the greatest natural disaster in American history. The hurricane in Galveston struck without warning. But today, scientists like Dr. Bob Sheets have the tools to know when storms are approaching.
That data they gave us on the high pressure area to the north really allowed us not to have to put the warnings up on the northeast coast.
As director of the National Hurricane Center in Miami, in 1992 he predicted that Hurricane Andrew would hit South Florida full force.
I'd have to say that Andrew was the most difficult experience we've ever faced. The destruction was unbelievable. However, because we're able to predict Andrew's track and intensity, the cost in lives was greatly reduced.
But with every approaching hurricane, Bob Sheets and his colleagues face similar life and death decisions. Right now, the satellite photos are showing a large storm called Emily, several hundred miles off the coast.
This one's really worrying me. She's starting to move fast and could become another Andrew. We've got to figure out if Emily's going to build in intensity or die out, and we really don't have much time.
The U.S. Navy ship out in the Atlantic reports that Emily is already generating big seas and powerful winds. With no weather stations at sea, there's only one way to find out what Emily's going to do. Fly out and meet the storm. That's the job of a team of scientists headed by Dr. Frank Marks.
Takeoff's a little uncertain sometime in the next 2 hours. Okay, let me know when you have a firm time. We've got to fuel the airplane. Okay, about 3 hours after takeoff, we want to do fix on the center. And we're going to do a drop-in sun pattern along the north side of the storm. And Hugh has all the points for new. I've flown through hurricane eyes about 300 times. But every one is different. You never know what you're going to find.
Emily is about 36 hours from the North American coast. There are critical questions to answer. Where is the storm going, and how strong will it be when it gets there? The plane will fly right into the center of the hurricane, the eye.
of the storm, we need to fly through the hurricane's eye wall, the most violent part.
Okay, so we got, 12 miles to the wall here? We have 3 minutes. 3 minutes?
Once we're at altitude, we strap everything down and get ready to punch into the storm.
We're about to go in. Secure all equipment. This one looks strong.
No matter how many times you do this, you always get a knot in your stomach just before you fly into the hurricane wall.
Okay, folks, seatbelt light is on. Here we go. Rock and roll. Nice sharp wall. This ought to be good. Okay, wind speed. Yeah, I've got about 25-degree correction. Airspeed 230. Okay, here we go. Okay, steady. Oh, good one. Hold your gizzard. All right. Good one.
After being tossed around by 120-mile-an-hour winds, the moment we break in the eye is just incredible. It's just so peaceful.
Center, no 43. We'd like to do a 180-degree turn.
I think it's a new eye wall form. An eye this perfectly shaped is a real thing of beauty, but it also means Emily is definitely strengthening.
Look at that sea state down there, David.
Our instruments tell us how fast the winds are circulating around the eye.
It's been windy over here for a while.
The Hurricane Center can't determine where the storm is headed until we've pinpointed Emily's center.
This looks like a great eye sounding.
Getting good data today. And you, number 25 is ready to be launched. Okay, let me know.
Roger, we'll be ready in 3 minutes.
The onboard computer creates a visible cross-section of the storm. The image is transmitted by satellite to the National Hurricane Center.
From no aircraft.
Boy, that's a well-formed eye. That thing is continuing to strengthen. Now the question is, where is it going to go? Whether or not we're going to have to extend those warnings. We're less than 24 hours. Naomi, do you have...
Actually, the model guidance is showing this ridge to the north very well established.
Okay, if that really stays there, the ADA model says it's going to follow that and come all the way
When the
in.
new information from the plane is entered into the Hurricane Center's computer models, the result is a prediction that Emily is headed straight for North Carolina. The scientists must now consider whether to recommend evacuating people along the 300 miles of North Carolina and Virginia coastline.
And the GFDL indicates that they'll brush here and then turn back out. So the question is how strong this ridge is going to be here. So we need to get some more data.
But I'm not sure the computer models tell the whole story. The question is, are we going to need to evacuate the whole Carolina coast or just the Cape Hatteras area? If those winds from the west are strong enough there, they could actually turn the storm back out to sea. We've got to get the airplane out in front of the storm to see how strong those winds really are.
Miami control is we've left the eye and re-entered the hurricane wall. We'll advise you when we reach the leading edge of the storm.
Okay, that's 105 knots.
Proceeding on to the next stop.
Miami Center, 043. Clear the eye wall and the northeast edge of the storm.
Once the plane gets out in front of the storm, the team prepares to drop an instrument pack called a windsonde. a metal tube with sensors and a radio transmitter inside.
Jack, the sound is ready.
It will send back readings on wind and air pressure at different altitudes.
Ready, drop. Ready.
Okay, Duke. Drop wind sound in position. Ready to release.
Drop it.
The information is sent immediately to the National Hurricane Center. Not a moment too soon.
This is our point of no return. Any evacuation decisions we make have to be made now. Do we recommend moving millions of people along the entire Carolina and Virginia coast, or just the area right around Cape Hatteras?
This is the latest NOAA recon data, and it's showing that high really built in there with ridge axis.
From the plane's readings, I'm betting Emily's going to get turned by the winds from the west and pushed back out to sea. It's going to be close over the Outer Banks and recurve, but it looks like we've decided to limit the recommended evacuation to the Cape Hatteras area.
Must leave the area by 10 a.m. All residents, evacuation has been ordered. Pack up and leave the area by 10 a.m. Hurricane evacuation has been ordered.
By 7 that evening, the storm had hit. Winds reached 80 miles an hour.
Now, these are the kind of calls that you really sweat over. In some ways, it's much easier to recommend evacuation of a large area. We just gotta hope that those winds from the west keep pushing Emily back out to sea.
Later, the winds increased to 90 miles an hour, with gusts up to 140 near Cape Hatteras, pushing the waves even higher. At 9 p.m., the storm was at its worst.
Gusts of 140 miles per hour have removed the from the Six can still secure that area. All units be advised, Brooklyn has had 7 inches of rain in the past 3 hours. Evacuation centers have been established at Bristol and
We came back tonight to find out how those homes were doing. They were precariously hanging into the sea as Emily was making her way up. Well, look, the 2 homes are gone. Absolutely wiped away, washed away.
By midnight, the storm turned out to sea, just as Bob Sheets had forecast. A large and costly evacuation was avoided, but the damage was grim. 3 people died.
No, we're scientists. We deal with numbers, probabilities, and statistics. But several years ago, I started keeping a list of people who died as a direct result of the storm. Who they were, how old, what had happened to them. I want to make sure that we never forget that we're talking about people's lives.
The successful forecast of Hurricane Emily shows the progress scientists have made in tracking hurricanes and assessing their force. But there are other violent storms that still defy our best attempts at prediction. Every spring, thunderstorms roll across the Great Plains of Texas, Oklahoma, Kansas, and Nebraska. Hemmed in by the Rocky Mountains, cold, dry air from Canada collides with warm, humid air from the Gulf of Mexico. Each thunderstorm has the potential to create an even greater threat, giving the region its nickname, Tornado Alley.
So our plan is to head up towards Lubbock and hope that those storms maintain rather high shear and eventually hit higher dew points.
10-2, we copy.
In April and May, Stormchasers from the University of Oklahoma take to the road in specially equipped vans, traveling up to 10,000 miles in search of tornadoes. Professor Howard Bluestein is a pioneer in tornado research.
It's looking a little bit better up there. We can tell from looking at storm structure which ones have tornadic potential. But why do a few thunderstorms produce tornadoes while most don't? How you doing? We set up a small radar to measure wind speeds in and near the tornado.
On the picture over there. Oh, look at the cyclonic curvature that wraps up back in the wall cloud.
Yeah, I know. That could do it pretty soon. Conditions can change very, very quickly, so we always have to be ready for anything. Okay, new game plan, people. Pack up, document. We're going to go back into Orla and move northeast and try to stay ahead of it.
Inside some of these storms, there's a large rotating vortex they can't always see from the ground. It's called a mesocyclone.
We are moving right now. This storm has a big gust front.
721, we're stopping.
There could be a mesocyclone in this. If there is, we don't see it from this vantage point. We're going to backtrack into the town Orla and then go northeast and try to stay ahead of it and see whether or not something develops. I'll bet there's probably some pretty large hail back in there right now.
You guys see the storms?
Hail forms when updrafts in the storm are so strong that rain can't fall. Instead, it remains in the clouds until it freezes and then drops to the ground as ice. That afternoon, they catch up with the storm, but no tornadoes form. It's not unusual for storm chasers to drive hundreds of miles in a day, looking for the thunderstorms that give rise to tornadoes. A thunderstorm begins when warm, humid air near the ground becomes unstable and rises, condensing into water drops to form a cloud. When the cloud grows and reaches the cold environment of the upper atmosphere, as much as 10 miles high, it flattens out, forming an anvil shape which spreads away from the base of the storm. Some of these storms become supercells, with upward moving air and rotating winds inside them. This rotating air sometimes extends down to the ground as a tornado, picking up dust and making the funnel visible. Hundreds of tornadoes touch down every year, but only rarely under the watchful eyes of tornado chasers.
Sound to me like a train going real fast over railroad tracks. It was really quite scary. And all of a sudden the lights went out and we heard the roar. I was really quite petrified because I knew the tornado had hit and my husband didn't come to storm shelter with me and I knew he was dead. Especially when we came out and saw all the rubble. I mean, to see the destruction was just unreal.
Peggy McGinley's husband did survive this tornado, but 17 others did not. 4 days ago, the field behind these houses contained hundreds of trailer homes.
We saw all kinds of debris flying around. At one point in time, I saw a cow flying through the air. And I heard my mom yell to me, "Brooke, lay down," and I yelled back, "I can't." And then my head started hitting the ground, and my body started hitting the ground, and it was like a rag doll just being beaten.
The Stormchasers' day begins early, looking for conditions that suggest instability.
The shear will be better up to the north because the surface winds are backed around. Well, I can't find this road on the map, that's the problem. But it looks to me as if we keep following it, it should take us right near the wall track.
West to get around Abilene. 380 east is faster. West looks a lot shorter.
Now maybe we should ask someone.
If we start to get overtaken, you can always move east. I'm worried about the surface winds. I don't think the winds have backed enough. They're still south or southwesterly.
I'll tell you what, why don't we go west on 51 here?
There's another possibility. We could go north just enough to get the sun behind the anvil, and we'll be able to see what's happening under the base. I wonder whether we can trigger something back along the back to our southwest.
When the team reaches their target area in Texas, they find a storm with significant rotation, but still no tornado.
Beautiful flank to it. Those are ring clouds ring around back to the southwest. And there are more thunderstorms way out to the west. Look at that bright.
Thunderstorms move rain, dust, and ice particles around, generating enormous levels of electric charge. This one produced 50 lightning strikes in 3 minutes.
When people ask me if I'm afraid of tornadoes, I always say I have a healthy respect for them. The thing that scares the daylights out of me is lightning.
All right, this is enough. Should we pull over?
Have to drive right through.
That was pretty impressive.
At sunrise, the team is headed north to Ponca City, Oklahoma, 500 miles away, where conditions seem promising.
The FC Red? Yeah, we just heard there's a severe thunderstorm warning for Sherman County.
They receive constant updates from the National Weather Service.
Out of the southeast feeding into this storm.
Are you seeing a hook echo?
The hook is very well defined, have a very strong inflow notch, and it's quite wrapped up. And if I look on the Doppler side, looks like I have a fairly rapid rotation toward the east.
Did you say east?
Yes, a little bit north of Dewey. Should be passing across the Marland exit. Should have an excellent chance of intercepting the storm. It looks very likely that we can get the tornado to spin up out of this fairly deep mesocyclone, so you'll have to hurry to get up to that area. But I think you have a pretty good chance of intercepting it coming in from the south side.
The National Weather Service issues a tornado warning.
Dew point's still below 50 all through here. So we have to be alert for it to suddenly go crazy.
Tornado warning now issued for Enid, Hunter, Billings, and Garber. Residents there are advised to take shelter right now.
Very rapid rotation in Beverly. It looks like we may be getting ready to set down something big in the Garber area. You might want to tell them to take cover now.
Yes, it appears that a developing storm just southwest of Garber is tornadic at this time.
We have a confirmed report of a tornado on the north edge of town. Where are you, Howie?
We're just south of Garber. We see a skinny funnel up behind it.
Pick it up. Let's go.
A funnel has been spotted near the town of Garber, Oklahoma. It's a delicate balance. Get close to the tornado, but stay out of danger.
Look for any noise we're looking. Rain curtain right there. The rain curtain right there. Just go up the road a little bit.
Daddy is rotating to my eyes. That's cyclonic fear in it. Sam? Come on. Differential motion, both sides.
By the time they get to the north side of Garber, the storm is highly electrified.
Hey, how's it going? It's 100. And I'm talking pretty quickly. That's all. Here comes the line. Let's get this going. Power on. You get a signal? Okay, zoom out over an hour. There it comes. Grab it if you're exposed to that.
Suddenly on the horizon, they can just barely make out the telltale signs. Wind kicking up dust whirls on the ground. The beginning of a tornado. They prepare their instruments to get readings on wind speed and rotation.
I got hit. Oh. The price.
Hurry up. Okay, scan a little bit. Start scanning, start a little bit to the right. And then
As quickly as it formed, the tornado fell apart.
But we got wind speed measurements of almost 200 miles an hour, some of the highest ever. Every time we document another tornado, we add an extra piece to the puzzle.
From a few essential elements, the rotation of the Earth, its land, water, and air warmed by the sun, comes the endless variety of weather we all experience.
Storms are always going to be more powerful than we are. But being able to predict a hurricane in Florida or the monsoon in India helps us deal with the forces of nature instead of being totally at their mercy.
Our ability to predict the behavior of storms is far from complete. And as long as there are pieces missing in our understanding, scientists will be out there chasing.
Just at the base of the cloud, getting ready to go in. This one looks bad.